So
Okay, so I just want to briefly talk about Kafka. So Kafka, it is a distributed publisher subscriber messaging system. So initially it was developed by LinkedIn, and then it got moved into a Apache open source. AWS has the same service, managed service. It's AWS MSK, managed streaming Kafka. So if we look at why do we need this distributed messaging system, the use case for Kafka, assume that if you look at this diagram, we have a bunch of microservices on the left side that are producing messages or events that need to be sent to one or more services on the right side. So for example, if the database slave, it has to send every record to database server for writing into the backend system, or it may also have to send a record to the security system for analysis, or maybe to another service for real-time processing. So basically, this guy, he has to make a three connections with all these three producers to produce this, to forward this message. So, and that would makes it things complicated because they are getting coupled with each other. They know who is a producer, and everybody has to have a connection with each other. So that would make us to create, a mesh of connections. Every producer, it needs to have a connection with every consumer. It's going to be an end-to-end connection matrix. And another thing is, the other places where we use the messaging system is if you have a spike of load, it would, if the processing system is not fast enough, the load could temporarily get buffered in the messaging system so that the consumer could catch up. And by having a messaging system, somebody in the middle, that would completely decouple producers from the consumers. If they are talking to each other, everybody is aware of who is a producer, who is a consumer. They have to maintain their connections and communication with each other. But if you put somebody in the middle, so this guy, what he will do is he will just put the message, this microservice, it will just put a message to one of the topics and he will forget about it. On the other side, you can have one service or multiple services. Whoever want to consume, they could just come up and subscribe to there, and they will be pulling the messages. This guy doesn't have to worry about if any new service has to subscribe to this. There's going to be, it's all seamless. He doesn't even know about any new service coming up and consuming the message. So basically, you don't need a mesh of connections. It completely decouples consumers from producers. That's the key benefit. And a periodic load could be buffered so that consumer can catch up. So even if a consumer goes down, there could be a node. So a consumer means it may be more than one node, right? A couple of nodes sharing the load. So if they're talking to each other, this guy would get to know how to rebalance. This guy would get hided from how many guys are loading sharing the load on the other side. If any node leaves, this guy doesn't have to worry about it. A new node could join on the consumer side to share the load. These are all seamless. It doesn't, the consumer doesn't even need to worry anything about it. That's the key benefit of the messaging system. So the same way, if you're adding a new heavy load, you could simply add another node, increasing the partitions, increasing the consumers. If the load is going down, you could simply take off the node from the cluster. Reducing the partitions. It all goes very seamless. That's the key benefit with the producer consumer messaging bus. So here you see, so we just simply drop the Kafka in the middle. They all will be decoupled from each other. It all goes seamless. That's the key advantage. So in Kafka, there are key components like producers are the clients who are publishing the message. Consumers are the one pulling the messages from the Kafka cluster. So what we'll have is in the cluster, there could be one or more nodes, and they are being coordinated and controlled by the zookeeper. So if there are more than one node, there need to be a leader. For this leader election and synchronization, you need somebody who could help with that. That's where zookeeper comes in. If they have any information that need to be, cluster specific, like who is a leader, that leader ID that could be stored in zookeeper. That way they would coordinate with each other. And as you can see here, like in Kinesis. So how they divide the load across the cluster is, so basically the terminology, if you just come to the terminology, so a broker is a node on the Kafka cluster, a physical node, um, which is part of the cluster which will hold the messages. And a zookeeper is the manager that coordinates between the brokers. A producer is the guy who produces the message, and consumer is the guy who subscribes and consumes the messages. So logically, what they do is whenever somebody want to produce or consume messages, they have to decide on the topic, and the topic is further divided into partitions. For example, if you look at our Slack channel, so we have a separate group for every batch, right? It's simply they might be creating a one topic. So I mean that's how they divide the load across the topics. Within the topic, they further divide the load by having multiple partitions. A partition will be residing on different nodes so that different nodes can take the load within the topic. So a multiple partitions together make a topic. So in Kafka, partition is a scalable unit. You could increase them or you decrease them. That's how you handle the load. And any messages that put on the message that are put on the Kafka, and they have an ordering is enforced. Ordering is enforced. So across the cluster, and also what you can do is you can also select how much is the replication factor. So here you have multiple nodes and you have one topic. Each topic you divide it into 4 partitions, and within that partition you could select a replication factor. Hey, I want 4 replicas for my message. So one of the guy who is going to be the main partition leader, he's going to be obviously going to have your own copy. And this guy, whenever he receives a message from the producer, he will replicate the message to another 3 replicas. That's how they maintain the availability part.
Yes, Siva. So regarding this, a quick question, right?
Yep.
So what you explained, the the messages, they're actually living on the broker. So basically a broker is a physical machine. Actually, is it
Right.
like
Right.
a,
If you look at
right?
here,
Yeah.
if you look at here,
Right.
you have a node. A node.
Correct.
And within a node, you could have multiple brokers. A broker is a kind of a logical entity, but it
I
should be
see.
sitting on a physical node.
Okay.
It should be sitting on a physical node. So
Okay. So broker is a logical entity. Yeah. Okay.
logical entity. Topic is a logical entity. Partition is a physical entity. So basically, I mean, each node, one of the brokers will be owning the partition. So the messages will finally land on one of the partitions. All these
I see.
partitions together form a topic.
Okay, so message go to the partition form a topic, and then when you said that replica, 4 replicas, like you said, right, of that particular
So
message.
this is for redundancy. So basically,
Correct.
I mean, any
Yeah,
of the nodes could fail, right? So you need to have a
I agree.
until the consumer comes and consumes them. That's where you have the replica factor.
So
Whenever you are
to that,
creating a topic, you select a replica factors. So
perfect.
once the producer receives the message, so basically that guy will replicate the messages to the replica. The followers of that partition.
Yeah, and that's where my question is, that when it replicates that message, right? So are these partitions itself replicated on different brokers?
Yes.
Because that complete partition would have to be replicated, right? I mean,
Almost like it. Yes. So the whole
yeah.
part. So basically, in this broker, you have a partition.
Right.
A partition it needs a backup. So every message that you put in on a partition, it needs a backup. So the partition backup is going to be sitting on a different node, different broker.
And then you can specify the replication at a partition level or at a message level, because now you see where I'm going. Actually,
it's at the partition level. I think I don't think you have a choice to select which message to I mean, that's too much of them.
I see. Yeah.
Right.
Okay. Yeah, just
And
You can,
yeah, please go ahead.
so I did not get the question about the partition. So is the question that how do we decide which partition the message goes to?
No. That's not the question. The question is about, okay, I want a replica of my message, right? Siva said there are, let's say I want to specify the replication factor of the message to 4, actually. Okay. So messages, as he explained, they're stored on that physical partition. Okay, that partition actually, right? On that broker on that node.
Yes.
So can you be picky choosy to say, I want to store only these messages, I mean, replicate these messages, or you have to, logically, it feels like you have to say that the replica of the partition, basically, so that whatever messages that are going to that partition are replicated like thrice or 4 times, or whatever you specify, depending on the application factor. So
I assume it will be the partition that's going to be replicated. I don't think we can choose a message.
Or the question is actually, or is the replication set at the topic level? I mean, which is
I think
even
it's a topic level. It's not even partition level. It doesn't make sense, right? I mean,
why would you? Exactly. Topic might make more sense actually, but again,
whenever you're creating a topic, that is the time you select the replication factor.
Replication factor, right?
So basically, this is how it goes. A producer produces a message, so we call it as a record. The record will have 2 things, 2 parts: key and value. Key is the optional field, value is the real message. So based on the key, it would decide on which partition this key should be set. So for example, you are streaming a lot of stock codes. So basically the key will be the stock ID, value will be the whatever the information regarding that the stock at that moment. So based on that, what the partition, what it will happen, the logic will make sure all the stocks for that, all the messages for that specific stock, because they're going to have the same key, they're all going to land on the same partition. That's how we are going to ensure the ordering. Hope you guys got it, right? And
yes,
Kafka gives a flexibility to write your own partitioner. So basically what we do is, so for example, you have some system which is producing messages or consuming messages. How they will publish the messages to the Kafka is, they're going to build the Kafka SDK as a part of the producer or consumer software. And then that guy, the library will connect to that Kafka cluster. He will figure out what are the topics are there, who is the leader for that topic. And he will find notes that where the message has to be sent. Where the message has to be sent. So basically, so that's the flow of the message. So based on the key value, we will decide on which partition the message should be going. And then, like we said, we'll select the replication factor, so that how many copies to be there. And each partition, they're going to be a leader for that partition. So all the messages for that partition, they will arrive to that partition leader, and that guy will forward the messages for backup replication to the followers. So how they're going to maintain the consistency is,
sorry, Siva, sorry to interrupt you. That partition has a leader. I thought, I thought the leader is really at the broker level, right? I mean, the broker.
There are 2 levels. There's a cluster leader and the partition leader.
Oh, I see.
Partition, there's going to be one leader for the top, and for the whole cluster, there's going to be one master.
So then the next question is like, if there is a leader at a broker level, cluster level, like you said, right? And then if there is a leader at the partition level, so can the partition leader be on a different broker than the leader broker?
I don't think we should get confused here.
Okay.
Leader there is to manage the whole cluster. If any node goes out, somebody should keep watching all this, right? That's where that master is.
Okay.
So here, this is a watcher for that partition. So basically, I mean, you are adding a new node to the topic to handle the more load and all. That's where this leader for that part comes in. Okay, so as you can see, so then coming back to the other topic, a consumer, a application that want to consume the messages, subscribe to the messages. That's what we call as a consumer. So the consumers, what they do is, for the same topic, there can be more than one consumer. So basically, an application receiving the messages and writing to the database or to the backend backup will be part of a one consumer group, and there is going to be another consumer group for a separate application which will read the messages and then process them for analytics or something. So each of this application will form its own consumer group. Within the consumer group, there are going to be multiple consumers. So each of these consumers will latch on to the specific partition. So that's how the load will get distributed across the consumers. So basically, you had two applications. They both could read from the same topic. So they're very independent. That way, consumer doesn't have to worry how many guys are reading my messages. Sorry, how many applications are reading, are processing my messages and all. It all will be seamless. It all will be hidden from the producer side. So basically, a topic could have multiple consumers. That's for load sharing, and there could be multiple consumer groups for different purposes of application. Okay, so and within the consumer group, only one consumer can own a partition to obey the ordering of the messages, because somebody is putting the messages in an order. If more than one guy is reading the messages, the ordering will be broken, right? They will make sure by having only one consumer owner for a partition. So the number of consumers is going to be number of partitions, at least minimum. That's how it is going to be. So a consumer can own more than one partition, but a partition cannot be owned by more than one consumer. So once there is a concept of called lag. So basically, whenever you write a message, if the producer produces a message, if the consumer hasn't consumed it, so that increases the lag by 1. So there is a fast producer, but there is a slow consumer. That's where lag will build up. Okay, so how this system works is, so basically, like I said before, there's going to be an SDK that's going to be built along with applications, and these are the SDK will mask all this logic of working with the cluster to figure out who is the topic leader, a partition leader. So to make a connection with it and read from there and all, it all will be hidden from there. So whenever you're writing a messages, you could batch the messages, you could compress the messages. That will give you efficiency for read and write. And also, each message put on that, it will have an ID. It's called an offset. So if, for example, if the consumer has crashed, the messages are not going to be gone. They're going to be there for a retention period. This guy will come back. If he has a copy of the offset where he has read, just the offset ID, he can just go back to the topic, start reading from the offset. And also, whenever somebody is writing messages, if it has to be serialized, right? It can be, for example, if it is a JSON message, it's easy. The library could do that for you. If it is some binary record, the consumer has to serialize the message and convert it into a binary stream so that it could be put on into the topic. So that's where we call it as a serializers. So, and Kafka also supports schemaless messages using Avero or other schemas. So basically, the concept there is each message will have a version ID, and they both on both the consumer and producer, they would have agreed on the message format. So that way you don't have to repeat the key names everywhere. For example, if you take the JSON format, many of the time you would see that the key name might be very duplicate, right? If you are sending an employee record, it will have employee name, employee ID, employee salary. So the name is going to be so we are going to have a key and value fields, right? The key is employee name, value is the real name. The key is ID, value is the real employee ID, which is an integer. So for every record, you are repeating that key names, right? that can be that overhead can be reduced by producer and consumer agreeing on the message schema format. So there are some libraries that would help. It is called Avero. One of them is a Avero library. So it will help to reduce the schema overhead between the producers and consumers. So that's all. Any quick questions so that I can answer?
No, this was very good actually.
Yep, that's all. So the key functionality I was pressing here is by having a message bus in the middle between these producers and consumers, it all will become seamless. So a new consumer joining the group, the producer doesn't have to know about it at all. If you are subscribed, if you're starting a new application to consume the same messages, the producer doesn't need to know about it. This guy will simply subscribe to the topic and start consuming the messages. Even if you take off that application, you don't have to worry. The consumer doesn't have to worry about it. So the mechanism is completely decoupled. So the producers and consumers are completely decoupled from each other. That's the key advantages. So
I agree, Siva, but and again, this thing, you must have heard about TIPCO and other things, right? Like the Enterprise Service Bus, the ESB, right? They also had the same concept. I think Kafka took it up at in terms of the throughput and the volume level. I think that they took the game up on that front actually, because messaging systems have historically existed, be it MQ series like I told you, or other ActiveMQ, RabbitMQ, TIPCO as an enterprise service bus. All of that existed, but these guys, took it to the next level actually.
Oh, okay.
So what used to happen with MQ series and other systems is that the producer had to keep track of from where the consumer is subscribing. So there was a lot of load on the producer. As you add more applications to consume, the load increases on the producer. So Kafka decoupled that part totally. Right. Producer doesn't have to worry about how many consumers are connecting. It's just the zookeeper is maintaining that there is no extra load on the broker at all. So that is how Kafka is able to scale to any level now.
Right. So we were talking about one example, right? I think last week, Archana was presenting a chart service application, right? So I could see one use case here. So basically, what we could do is, we could take the user ID and shard it into a topic. So the node that has a WebSocket from user 1, it will simply put the message on the corresponding topic based on that user ID. And there
create a topic for a user. So save all the messages for one user on one topic.
Not one user, I would say that may be too much. Shard the based on the user ID and then find out the topic name and just put it on the topic.
Partition based on the user ID. In
that
case you will get the user messages in the same order.
Yeah, and that way on the other end you could have another node which will pull messages from there, and that guy will forward to the corresponding receivers of the message. And then you can have a one node or multiple nodes. This guy doesn't have to worry about it, and this guy doesn't have to make any direct connection with the other side of the node. If that other node is gone, this guy doesn't have to worry about it. The messages are simply going to be lying there for some retention period. When the node comes up, it will simply work on the messages that were queued when this guy was crashed or rebooted or whatever. So,
but for a particular partition, a partition could have multiple users, right? Although it's not like partition by user ID, right? Because if you get one partition per user, that will be a lot, right?
Right. For example, if you see here, initially, so basically, the producers are putting the messages into 4 partitions. But on the other end, we have only 2 consumers. So both of them are pulling from 2 different partitions, sharing the load. If the load becomes too much, you could add another consumers. The Kafka will rebalance the partitions so that each consumer will own one partition. So that's how the load is handled. And remember that consumer and consumer group, the two are different concepts. So whenever
Yes.
you have an application which is processing the same messages, each of that application has to create its own consumer group and read the messages. And within the application, within the consumer group, how fast you want to do, how much throughput you have to provide processing the messages, that you handle by increasing the number of consumers within the consumer group.
But you cannot have more consumers than the number of partitions.
That's
So
correct.
that's one thing you have to know before creating the topic. So you have to do the sizing before creating the topic.
You're absolutely correct. Number of consumers should be less than or equal to number of partitions. Because a one partition can be owned by only one consumer. Otherwise, the ordering logic is broken, right? The serialization, the sequencing order of the messages will be broken. So that's why they limit it. Yep, that's all. That's all from my side.
Very good document. It clears
Nice
the
document.
concept.